Hi, and welcome to another Hopper video. This is Hopper 6502 assembler video, and specifically again targeting the 650 WINU from Anders Nielsen, and trying to come up with a little sprite engine to write some games. I promised I'd do one of these if it's a follow-on to my sprite video and a follow-on to using the Hopper 6502 assembler. Short in a nutshell what the game's about. If I reset it here, it's basically illustrating a sprite engine, sort of same kind of games. There's lots of games that work this way, where you have the scene moving across, scrolling across the page, and you have the user sitting stationary on the left there. I can make the user go up and down. Across the top are how many lives I've got left. So these little things up here, how many lives you got left. Scrolling across the screen, the square blocks are bad things. If they hit you, you lose a life. The little dots are good things. If you chomp one of them, you gain a life pill. When the game ends, it freezes on the screen. If there's a green light on when it ends, it means you won. We ran out of, because we're using the same sprites for the life tokens at the top as we are for the game. When it runs out of sprites to give you, that means you've won the game. So now it's frozen without a little green light on. So that means that we lost the game, because I haven't bothered putting in fonts and text. So yeah, the thing's got a built-in LED, and that little LED will come on if you've won the game. So let's start it up again. So anyway, you've got to go chomp these things if you want to win, but there's no way I'll do it on video. I mean, if you could see my video setup, you'd understand why. It's kind of hard to get your fingers in there. And this is my super sophisticated game controller. It's got an up and down, and they're going into two of the pins of the riot chip, IO pins, debounce them sort of. But it isn't really about the game. There's a lot of things wrong with the game. My random number generator is not terribly random. I've just got a big table. It's got to generate numbers between 1 and 15 for the y coordinates, where it spawns things on the right, and I've just got a table that I got ChatGPT to make for me of random numbers, 256 instances of numbers between 1 and 15 that are in a pseudo-random order. So my random number generator is not terribly sophisticated. All right, so structure of the program. I'm using the Riot interface that Anders wrote, same thing, because it's on his board. I've got some utilities. I don't really use the delay utilities. I've got some for turning the LED, the built-in LED on and off. I just use it to show a positive game over, like if you won, but it was really useful for debugging as well. And then in the main loop, let's go look at that. Bottom of the program here. What does it do? Initializes the display, initializes the buttons, clears the display, and then it starts a new game, which populates you with 4 little life pucks, and starts the game with you in the middle on the left. And then in the main loop, it's checking for collisions, which tells whether in the left-hand column whether you hit a little life puck or you hit a block. And then if you run out of lives, it exits the game. Checks if button 1 is down, checks if button 2 is down, and that causes the left-hand sprite. I've used sprite 0 for the user control on the left. Will go up and down depending on whether and it stops at 15 on the way down, stops at 0 on the way up. So or at 1 on the way up. So if it's not 1, it'll decrease. If it's not 15, it'll increase. And then in the game loops, the game loops around pretty quickly in this loop. So every 30-second loop, it's going to spawn a block. And then every 64th loop, but offset from the block spawning, it'll spawn a life pill, which means there's less life pills than there are blocks, which means it's actually easier to lose than it is to win, in a nutshell. And then every 4th time round in this lap, it moves everything. It moves all the scrolling pieces move to the left by 1. So this thing could be 4 times faster if we wanted to, but it's at this, moving every 4th loop, seems to be a good way to, you know, it's a reasonable way to, a reasonable speed to play at. Okay, let's have a look at the libraries. We'll start at the bottom. The I2C one is essentially what Anders wrote for I2C, but I've made it very specific to this display. I've locked it down to one I2C device. And my main reason for that was saving memory, to use as little memory as possible, because we've only got 128 bytes of RAM. And then I'll show you in a second how I used them. The utilities I've shown you, I2C was Anders's. And then display, this is actually my display code from the Hopper drivers for display, and then I ported this to 6502 assembly. And the main reason I used my code and not Anders's code is because I was very familiar with the layout. And I discussed that in the sprites video, which I'll link to at the end of this video. So I'm very familiar with this layout of the screen so I preferred my initialization so that I didn't have to figure out what the layout was. And maybe Anders's layout's exactly the same, I don't know. And then I've got a couple of utility APIs, GoToXY. And I've got two global variables, cellx, cellY, that I can use on all sorts of methods that where you call a method to do something with the coordinates. And the cells range as per my sprites video. X is 0 to 31, Y is 0 to 15. And I use the top row for those life pucks, so it's not part of the game field. Yeah, so go to there. What it does, this is in the display driver, so this will move the sort of the cursor inside the display so that it's going to draw into that cell next. And then I've got a right column instruction that draws out, and I've explained this in the other video on this device, on the layout of the device, which I think was written in Hopper, I can't remember, before I ported it to 6502. But the 6502, it works the same as the Hopper version. And so I've got right column, which writes 8 little vertical bits, 8 little vertical pixels in a column, and clear will clear the whole screen. And that's the extent of the video driver. So the video driver has a clear, it has a write 8 vertical bits, and it has a go to XY to move you before you write the 8 vertical bits. Right. And that's all you need. So if you go and have a look at the sprites and you go right to the end, render slot, it renders a 4x8 columns of pixels. So when you render a cell at XY, it has to render 2 cells. So it'll render the one above and the one below, depending on which. It doesn't matter which one you ask to render, it's going to render both of them anyway, and it's going to find the sprites in those 2 cells, if there is one or if there isn't. If there isn't, it'll draw a blank one in the other one. And then render slot calls that column display, which draws 8 vertical bits 4 times to draw an 8x4 column. So that's how we render to the screen here. So render cell, render slot, very few APIs. Render will iterate through all the sprites and render the cells for all of them. So if 2 sprites are sharing the same slot, there's a little bit of an inefficiency. It'll draw that slot twice. Don't really care. You can't really see it. And all through the code, I've got these little S's and Y's and X's and stuff. And that's just the memory map of my structure of a sprite. Since my sprites fit in 2 bytes, they're 16 bits wide, and these are what the 16 bits are defined as. And I just kept putting them around so that I'd remind myself, what am I looking at, the most significant or the least significant byte of this thing? And you kind of, I was losing track. Yeah, and there's a couple of obvious APIs in the sprites library. You know, is there a visible sprites in this location? And again, so it's looking in cell X and cell Y, these global variables. And so many of these APIs will use cell X and cell Y. So is there a collision at cell X, cell Y? And by is there a collision, we're asking if there is a solid object occupying that space, because we're normally checking for the left column where our user puck is, but we could be checking anywhere on the screen to check if that same cell is also occupied by a solid sprite. And the sprites have a Z order as well, so just for fun I made it so that the blocks go over your little circle on the left and the dots go behind them, so it looks more catastrophic when you get hit by the dot. It's not that exciting, but it's fun. Moves all the sprites. So again, it iterates through all the sprites. It checks to see if it's solid or not, if it must move it or not if it's solid, if it must scroll it or not, which actually does the same thing, because all the sprites that can move are also solid in this game, with the exception of our puck moving down, up and down on the left. But this is moving the sprites in the field. And yeah, so it's moving them left. And there's an exception. If it gets to the left end of the screen, it wipes them out and throws them back into the free sprites bucket so that they can be recycled with new spawning sprites. What else have we got in here? Move 2. This is used by Move. I believe it calls Move 2, does it? Yes, calls Move 2. And again, select ly, it takes 2 arguments. So it takes the sprite in the A register and moves it to position select ly, which means the first thing it'll do is it'll render a blank at its current position. So it'll go and fish the current position of the sprite out of the sprite itself, render a blank to hide the old position, and then it'll move to this. It'll set the coordinates of the sprite to the x and y, and then render that cell again, the new cell now, to show the new position. That's how move works. What else have we got in here? I've got about another 100 lines to go. Get available. This looks into the list of sprites to see if there's a free one available. And I don't need to. I was using this for debugging. See, I told you the LED is handy for debugging. We can turn it off here. Don't need to. So, like, if I was hanging in a certain function, the LED would be on. If I was hanging in here, for example, or if I was never calling it, you'd never see the LED. You could use the LED. Just a single LED is super useful for debugging. So yeah, this finds us an empty slot, and if we run out of empty slots to spawn pills, then we've won the game. And you know, you've got a lot of. At that point, you'd have a lot of pills sitting on the top row here, and good enough, the green light goes on and you're done. I'll show you where that code is. Random, I've already mentioned. Now let's have a look at the memory use. This is the interesting part. Wasn't very efficient with the sprite definitions. Don't really care because we've got an enormous amount of ROM. So if we go and have a look how big this program is, 65 GASM, I think it's called a game. It's 1400 bytes, so still less than 2K, and we've got a 4K ROM. So don't really care about efficiency for the ROM right now. So yes, I could have defined a sprite in 2 bytes per sprite, but I just defined them in 4 bytes per sprite with the top half empty. It was just easier from the code perspective. And I put all the sprites in a single array so that I could index them easily. And I cheated with the indexes of where the sprites are, because in the Hopper version, the first sprite is at index 0, then index 1, index 2, etc. And here I just put them in multiples of 4, so I can just use. I don't have to translate between a sprite index and an address in the sprite definitions. Total number of sprites right now is 16. With my game logic, the way I spawn them, you can't. Well, the only time you chew them all up is when they end up in a row of life pills at the top of the screen. 16 is plenty sprites, and we're using one sprite on the left for our user game control, and the ones across the top of the screen are also so these little ones at the top of the screen are also sprites, and that one on the left, our game control, is a sprite. So yeah, 16, if you look right now, it seems like you've got more than 16 things going on, but there's never more than a total of 16 sprites visible on the screen. Okay, let's look at the memory. So each sprite uses 2 bytes in memory, and they're the first thing in the 0 page, starting at address 0. Then I start what Anders calls userland, so where all my variables are, is at this, the address of sprites, which is just 0, plus number of sprites times 2, since they're 2 bytes each. So it'll be at address 32 or 20 hex. And then from there, I've got the entire program uses 11 variables, so 11 more bytes. So the RAM used by this game is 32 plus 11. So so 43 bytes for the entire game in RAM, and that leaves the rest of our 128 bytes for the stack, and the stack isn't being called nearly that deep. So there we can see we just had a game over. It stopped again without us winning. We could try and stack the dice a little bit. The random's going to be not very random, so it'll be more or less the same. But the way you can make it more random is by moving around a little bit and catching some things. There we go. We caught some life pills. Now let's just let it sit there and see how it does. Okay. What else have we got to show you? Oh, I can go back to the main loop again, or to the collision. Let's go look at collisions. So how does collisions work? Well, it calls that method I mentioned with collisions, which goes through all the sprites and sees, and it looks for this position here, which is the left-hand column x0 and the position y-pos of our current game position. And it checks if there are any moving game solid objects that collided with that position. Because their one just collided now, but when they do collide with it, it can draw more than one sprite in the same place. It uses the Z to decide which one gets to draw. It draws on top, so it finds the one with the biggest Z and draws that one in front. Okay, in the collisions, we check to see if the index matches, because the index is with those multiple of 4. It's ended the game again. So it checks if it hit a block, or it checks if it hit a pill. And then the two conditions: if it hits a block, you're going to lose a life. So it needs to get rid of one of those life sprites on the top of the screen, decrement your number of lives, and carry on. And, you know, re-render yourself in that same cell position, because right now there'd be a block visible there. And then if you hit a pill, it does the opposite. There's an add life method that gets used right at the beginning of the game to add the first 4 lives, so it reuses that. So again, it removes the pill, adds a life, and then re-renders your game paddle so that you can see it again. And then let's go look at the end of game conditions. So if your lives are 0, after checking collision, it checks the life count, and if your lives are 0, you've got a game over like we have now, where it's frozen. And then the winning condition for is under spawning. So if we're spawning pills, right? So the way spawning pills says is, get me an available free empty sprite out of those 16. If there's one free, give it to me. And if it's not 0, it comes in here and spawns a sprite. And then else, turn the green LED on and exit. You've won. So we've run out of sprites too. We've run out of ammunition. You know, the guy's trying to get at you, you've run out of ammunition, so you've won. That's simple. Yeah, but you get to see a lot in this. I'll post a link to where the source for this is on GitHub. And you'll get to see a lot of the detail of how I've used the Hopper 6502 assembler to write this program. So you've got ifs and elses, you've got loops, yeah, lots of interesting expressions, you know, to calculate things, and yeah, constants, constant arrays. So I'm right-clicking to navigate around. So these kind of arrays of constants that you can use, and how you position things on the 0 page. So there's a lot of good material in here from a tutorial perspective to figure out how to do it. Anyway, yeah, let's switch back to Anders's page, and we'll fade out. And let's start the game again, why not? And at the end of this, I'll link to the sprites video and to this playlist of all the stuff I've written for the 6.5 Arduino so far, and there might be more in future. So thank you for watching. Please subscribe, please hit the like button, and yeah, watch more on this in the 6.5 Arduino playlist if you're interested.